Okay, good afternoon. Am I audible?
Yes, ma'am.
Okay. So in last lecture, we have started numericals on overhanging beam. Okay. And we have solved one numerical. And I think one numerical given for homework. Have you solved this example? Yes. In last lecture, I have given one example for homework. Have you solved? Okay, so today we will continue next example. I will draw figures simultaneously. You can also draw. Then we will solve this example. Okay, so I will draw figure here. You can also draw. One overhanging beam is given, and on that couple uniformly distributed load and point load is active. This is A point. At B point, one moment couple is applied and the intensity of couple is 25 kilonewton meter. 25 kilonewton meter. This is B point. After that, at C point, uniformly distributed load is applied. Uniformly distributed load is applied, and this UDL is continue up to a remaining portion. So this is C. Here D point. Here D point. This is 0.5 meter. This distance is 2 meter. And this is E point. And this is F point. Okay. And at D point, one point load is applied and the intensity of point load is 50 kilonewton. 50 kilonewton. And this span is 2.5 meter. This is 1 meter and this is 1 meter. So 1 plus 1 is 2, 3 and 3, 5, 7. So total span is 7 meter. Okay. So this is the question. And we have to draw shear force and bending moment diagram for this overhanging beam. So whenever we will start solving problem, at that time our first step is
Calculation.
reaction calculation. First step is reaction calculations. In reaction calculation, A part, that is summation FV, which is equal to 0. That means we have to take addition of all vertical forces. So in this step, we will consider upward forces positive, downward forces negative. So according to these sign conventions, here one reaction is present at A point, we will call RA, and one reaction is present at E point, we will call RE. So RA and RE forces going upward. So RA plus RE. After that, this 25 kilonewton meter, we will consider in vertical forces or not? Not, because of this is the movement couple. Okay, and we are dealing only vertical forces. Okay, after that, this UDL and the intensity of UDL is 10 kilonewton per meter. Okay, 10 kilonewton per meter, and this going downward direction. So minus 10 into per. We have to convert this UDL to point load. So we will multiply by span. So 2.5 plus 5, 0.5 is 3 and plus 2 is 5. Okay. And after that, this 50 kilonewton force is there, and again this is going downward, so minus 50, which is equal to 0. Now we will shift this minus 10 into 5 and minus 50 to right side. So RA plus RE, RA plus RE, which is equal to 100. So this is our equation 1. After that, second part, B, summation movement at A point, which is equal to 0. We will take movement at A point, and for this clockwise force movement we will consider positive, anti-clockwise movement we will consider negative. So we will start from this E point. Okay, we will start from this E point. So this RE creates anti-clockwise movement towards this A point. So minus RE into perpendicular distance is this 3 and this 2 is 5 meter. Okay. After that, we will move towards this uniformly distributed load. So this creates clockwise movement. So plus 10 into 5. This is UDL to point load. After that, it will act at 5 by 2. Okay, but from this C to A distance is remaining. So we have to add 2 here. Okay. After that, next force is this 50 kilonewton and it creates clockwise movement. So plus 50 into perpendicular distance is how much? 1 plus 1 plus 2.5, that is 4.5, which is equal to 0. Now we will shift this minus RE into 5 to right side. Okay, so what is remaining here? 10 into 5 by 2 plus 2 plus 50 into 4.5. You do calculation for this and tell me how much. Yes. 425, something like that. Huh?
450.
450. Okay, so RE, which is equal to 450 divided by 5. No, I think you have done some mistake. Please check once again. Yeah, we have done here one mistake. Anyone please tell me which mistake we have done here? One moment is we have not considered here, which is remaining. So in moment calculation, we have to take this moment couple, na? And this creates anti-clockwise. So here, okay, I will write here. First we will cover this 50. So plus 50 into perpendicular distance is 4.5, and after that we have to consider this moment couple in the moment calculation, and it creates anti-clockwise movement. So minus 25, which is equal to 0. Now 425, which is equal to 5 RE. 5 RE. So RE, which is equal to 425 divided by 5. So now you tell me RE. Yes, RE, which is equal to 85 kilonewton. Now we will put the value of RE in equation 1 and we will calculate the value of RA. So next step is put RE in equation 1. So our equation 1 is RA plus RE, which is equal to 100. So RA, which is equal to 100 minus 85. So RA, which is equal to how much? 15? Yes, 15 kilonewton. So this is the value of RA. Now we will write here RA, which is equal to 15 and RE, which is equal to 85. Next step is shear force calculations. Shear force calculations. So we will start from this A point. Okay, we will start from this A point. So at A, upward force is there. So shear force at A, which is equal to plus 15 kilonewton. 15 kilonewton. After that, Now at B point there is no vertical force, and in between A to B there is no vertical force. So shear force at B, which is equal to, as it is, shear force at B, which is equal to plus 15 as it is. Okay, 15 kilonewton. After that we will move towards C point. You observe here, in between B to C there is no force, and at C point there is no any particular force. So shear force at C, which is equal to, again same, plus 15 kilonewton. Now we will calculate shear force at D point. Okay, shear force at D but before point load. Okay, shear force at D but before point load. Shear force at D but before point load. Before point load. Okay, before point load. So which is equal to, up to this C point shear force is plus 15. Okay, and in between C to D there is downward uniformly distributed load, and downward, so minus 10 into, okay, we have to multiply by the span, and in between C to D span is 2.5. So you calculate and tell me shear force at D, which is equal to how much? Yes, minus
0.
0, no, minus 10, right?
Minus 10.
Yes, minus 10 kilonewton. Now you observe here, at D point the
Hello,
shear,
ma'am.
yes,
0 ಏನನ್ನ ma'am?
so 0 येईल.
Minus.
10 into 10 2.5 किती असतो? 15 असतं का?
Yes, ma'am.
करा बरं कॅल्क्युलेशन. जर 2.5 into 10 1.5 15 असेल तर 1.5 into 10 किती असेल मग? हा, 2.5 into 10, that is 25. So 15 minus 25. So minus 10 answer will be there.
Yes, yes, ma'am.
Yes. Okay. Now we will calculate shear force at D point, but after point load. So we will consider here point load. So shear force at D after point load. After point load. So before point load value is minus 10, and at D point downward point load is there and intensity is 50. So shear force at D, which is equal to minus 60 kilonewton. Okay, after that we will calculate shear force at E. So shear force at E before RE. Okay, before RE, because of here in between D to E there is uniformly distributed load. If there is no uniformly distributed load, then we will calculate at exactly at E. But here load is there, so first we will calculate before RE. Shear force at E, but before RE, which is equal to, up to this D point shear force is minus 60. Now in between D to E there is uniformly distributed load, so and this again acting downward, so minus 10 into, now you tell me span for this, how much span for this? Okay, we are calculating at E point. Up to D point already we have calculated. So span for this, which is equal to how much?
0.5.
Yes, 0.5. Yes, because of up to D point already we have calculated. Now we are dealing in between D to E. So span is 0.5. Now you calculate and tell me. Shear force at E, which is equal to how much?
Minus 65.
Minus 65 kilonewton. Okay, now we will calculate shear force at E, but considering this RE. Okay, so next point is shear force at E, but after RE. After RE. after RE, which is equal to. So up to this E point, shear force value is minus 65. Shear force value is minus 65. Now we will add this. Okay, now we will add this. This is going upward direction, so this is plus 85. So you calculate and tell me shear force at E, which is equal to plus 20 kilonewton. And last point is remaining shear force at F. Shear force at F, which is equal to, okay. So up to this E point, shear force is plus 20. Now you observe in between E to F, downward uniformly distributed load, so minus 10 into 2, which is equal to 0 kilonewton. So these are the shear force calculations. Now we will move towards next step, that is bending moment calculations. Okay, before that, you observe here one point is there. At this point, shear force changes sign. Which point is there? असा कुठला पॉइंट आहे त्या पॉइंटला शियर फोर्स साइन चेंज होतं.
Point E.
Point E or D? You see now at C point plus 15 kilonewton and at D minus 10 kilonewton. That means sign is changed in between C to D. In between C to D. So we will find out this. Okay. So shear force is 0 at X meter from C. मी सी पॉइंट पासून घ्यायचं का ठरवलं, तर इथे बघा आपल्याला लक्षात काय आलं की सी पॉइंटला प्लस व्हॅल्यू आहे आणि डी ला मायनस आहे. म्हणजे शियर फोर्स हा सी टू डी मध्ये काय असणार आहे, कुठेतरी एक पॉइंट असेल की तिथं तो 0 आहे, तर ते आपल्याला फाइंड आउट करायचं. तर त्याच्यासाठी मग इक्वेशन काय आहे आपलं इथं, प्लस 15 मायनस 10 into, instead of this 2.5 meter we will consider x, which is equal to 0. So 15 which is equal to 10x. So x which is equal to 15 divided by 10. So x which is equal to how much? 1.5 meter. But from which point? From C point. Suppose I have to find out from this D point. So how I will calculate x which is equal to how much from D? Okay, I have to find out from D. बघा सी टू डी मध्ये स्पॅन किती आहे हो, 2.5 मीटर. ओके, आणि त्याच्यात आपल्याला लक्षात आले की 1.5 मीटर म्हणजे सी पासून 1.5 मीटरला इथे कुठेतरी काय असणार आहे आपला शियर फोर्स 0 असणार आहे. सो 2.5 मायनस 1.5 विच इज इक्वल टू 1 मीटर फ्रॉम विच पॉइंट, डी पॉइंट. ओके, लक्षात आलं आता हे. Now we will move towards bending moment calculation. Okay, wait, I will take new screen. Once again, I will draw figure here. So we will calculate bending moment easily. Okay, the value of RA is how much? RA 15 na? And RE I think 85. Please check. Now we will calculate bending moment. So step number 3 is bending moment calculations. Bending moment calculations. So we will start from this F point. We will start from this F point. So now you tell me bending moment at F, which is equal to how much? Yes, bending moment at F, which is equal to 0, because of here load is there, but perpendicular distance is 0, and the intensity of this point load is 50, and uniformly distributed load intensity is 10 kilonewton per meter. Okay, so bending moment at F is 0. Now we will calculate bending moment at E point. Okay, so bending moment at E, which is equal to, so for this I will draw span here. So this is our E point and this is our F point, and here 10 kilonewton per meter load is applied and distance is 2 meters. So according to this pushes downward, that means negative hogging type of nature will be there. So minus 10 into 2. This is UDL to point load, and after that it will act 2 by 2, which is equal to how much? Minus 20 kilonewton meter. After that we will calculate bending moment at this D point. So bending moment at D. Okay, I will draw span here. Here 85 kilonewton. This is 2 meter and this is 0.5, and this is 10 kilonewton per meter. Okay, so this 10 kilonewton pushes downward, that means minus 10 into, first we have to convert into point load, so 10 into 2.5, and after that it will act 2.5 by 2, and then we will consider this 85. So 85 pushes upward, that means plus 85 into perpendicular distance is 0.5. Okay, so this is our D point. You calculate and tell me bending moment at D, which is equal to how much? At D point 50 kilonewton force is there, but I have not considered because of this acting at D point. So perpendicular distance is 0. That's why I have not considered this. Yes, moment is how much? 11 point.
11.25.
Okay, 11.25 kilonewton meter. After that, we will calculate bending moment at C. Okay. Okay, before that, we will calculate maximum bending moment, because of in between C to D, shear force is 0 at 1.5 meter from C. So we will calculate maximum bending moment. Maximum bending moment, which is equal to maximum bending moment, which is equal to. So I will draw span here. This is 85. Here also in between C to G, again UDL. Here 50 kilonewton. This is 0.5. This is 2 meter. And from D, point is 1 meter. Okay, already we have calculated. So this is D. And suppose this is our point of contraflexure, we will assume as a small e. Okay. Now we will calculate maximum bending moment, and the intensity of UDL is 10. So this pushes downward, so minus 10 into, first we will convert this load and then we will multiply. So 10 into distance is 1 plus 0.5 plus 2, that is 3.5. Okay, 3.5. After that it will act at 3.5 by 2, because of this is only UDL to point load and this is multiplying distance. Next we will consider this 85. So it pushes upward. So plus 85 into perpendicular distance is 1.5. Okay, after that 50 again pushes downward, so minus 50 into perpendicular distance is 1, which is equal to, so you calculate and tell me bending maximum bending moment, which is equal to how much?
16.25.
Yes, 16.25 kilonewton meter. Okay, after that we will calculate bending moment at C. So next point is bending moment at C, which is equal to, we will calculate from this left side because of here less number of forces are there. So I will draw span here, here 15, this is 25, this is 1 meter, and at C this is 1 meter. Okay, so this pushes upward, so plus 15 into 2 meter. Okay, this 1 plus 1. After that this 25, this movement pushes downward, so minus 25, which is equal to, so you calculate and tell me how much? Plus 5 na,
Yes, ma'am.
plus 5 kilonewton meter. After that we will calculate bending moment at B with couple. Okay, so bending moment at B, that means considering couple, with couple, so which is equal to, so span is here 15 and here 25, here 25, and this is 1 meter. So now you tell me this 15 pushes upward, so 15, so 15 into 1, and this 25 pushes downward, so minus 10, which is equal to how much?
5.
Yes,
मैम -10 नहीं समझ
-10 कसे आणणार?
25, yes 25, because of the intensity of movement couple is 25, so minus 25, which is equal to, now
-10.
yes, minus 10 kilonewton meter. Now we will calculate bending moment at B, but before couple, that means without considering couple. Bending moment at B without couple, without couple, which is equal to, so only one force is there na, 15, and perpendicular distance is 1, so which is equal to 15 into 1, so which is equal to 15 kilonewton meter. And last point remaining as at A point, so bending moment at A, which is equal to how much? 0, because of 15 kilonewton force is there, but perpendicular distance is 0, so 15 into 0, which is equal to 0 kilonewton meter. So these are the bending moment calculations. Now we will draw shear force and bending moment diagram. Okay. First I will draw original beam, then we will draw. Here B point is there. After B, here C point is there. Yes. Now all points are over. I will mark figure here. So this is A point. At B point, one moment couple is applied, 25 kilonewton meter. This is B point, this is C point, and from this C to remaining span, uniformly distributed load is applied at D point. 50 kilonewton point load is applied. So this is D point, this is E point, and last one is the F point. So this is 1 meter, 1 meter, 2.5 meter, this is 0.5 meter, and this is 2 meter. So this is our original beam. We will write reactions also here. So reaction at A, RE, which is equal to 85, and reaction at A, RA, which is equal to 15. So we will draw first shear force diagram. So I will draw first baseline because of plus minus values are there. So shear force at A is 15 kilonewton, right? And this is continue up to C point because of there is no any force. After that, in between C to D or at D point, shear force which is equal to how much? Shear force at D which is equal to, we will see here, shear force at D is minus 10. Okay. And before point load and after point load, shear force is minus 60. So something here up to this minus 10. After that, it sudden drop down up to minus 60. After that, shear force at E. Shear force at E which is equal to how much? Minus 65. Okay, shear force at E is minus 65. So likewise. Okay, after that, shear force at F. Shear force at F which is equal to how much?
0.
0. But I think before that we have calculated 1 point. Shear force at E before RE is minus 65 and after RE is plus 20. After RE is plus 20. That means this diagram sudden goes above and this is plus 20. So above this 50. After that, shear force at F which is equal to 0. So it will close like this. This is the shear force diagram. I will mark values here. So this is A point, this is B, C, this is D, this is E and F. Okay. So here 50, at B again 50, at C again 50. At D, here shear force is 10. After that, here 60, here 65, and here plus 20, and here 0. So this is positive, this is negative, and again this is positive, and this is the point of contrast shear, and this distance is 1.5 meter from this C point. Okay. So this is the shear force diagram. Now we will draw bending moment diagram. The value of bending moment diagram, I think plus minus values are there. So we will draw first baseline, then we will draw figure. Suppose this is our baseline. So bending moment at F, we will first mark points. Bending moment at F is 0. 0. After that, bending moment at E which is equal to
Minus 20.
minus 20. That
Right.
means below baseline. Suppose here. Okay. After that, next bending moment at D. Bending moment at D which is equal
11.25
plus or minus.
plus
Bending moment at D plus 11.25. So it will be here 11.25. After that, we have to extend this maximum bending moment line. Okay, because of at this point bending moment is maximum. So value of maximum bending moment is
16.25.
16.25. So we will mark here. Mark here. 16.25. After that, next bending moment at C.
5
Plus or minus?
plus 5.
Plus 5. So here something below 11.5. Suppose here 5. After that, bending moment at B. Okay, at B there are 2 points, before couple and after couple. So with couple value is value is plus 15.
By ma'am with couple minus 10.
Okay, minus 10. Okay, here suppose minus 10, and without couple value is plus 15. So I think below this point. Okay, up to this here. So here 15 and here 10, and bending moment at A is 0. Now you concentrate here. Okay, up to C point, the bending moment connection is linear line, and from this C to F, bending moment connection is parabolic because of here uniformly distributed load is applied. So I will connect this to C point. After that, E to F, we have to draw parabola. So I will draw parabolic connection. Without couple 10, like
मॅम आधी 15 ला कनेक्ट करायला पाहिजे होतं ना 0 पासून.
first we will calculate without couple, na? Yes. We are starting movement from this side, na? Now curve, because of we are calculated movement from this side, so your answer is correct. Okay, so this is the bending moment diagram. This is negative, this is positive, this is again negative, and this is positive. This is the bending moment diagram. Okay, please write down fast. So we will take next theoretical point. Okay, instead of writing, I will suggest please take screenshot and after that you will continue this write up because of you we have to time limit. So please take screenshot. Today we will close this unit number 5. So last theoretical point is remaining. Okay, you have taken screenshot. Shall I show next slide?
Yes, ma'am. Yes, ma'am.
Okay. Because of after theoretical point, we will solve one problem. In that, horizontal force is given. Okay, shall I move towards theoretical point? Yes.
Yes, ma'am.
Okay. So please write down last point of this unit. First, we will see what is meant by point of contraflexure. Please write down point of contraflexure. Point of contraflexure. For this, first I will draw figure simultaneously. You can also draw. Then I will explain. Suppose here overhanging beam is given. This is shear force diagram and this is bending moment diagram. This is bending moment diagram. So you observe here. So these 2 points is called as point of contraflexure. These 2 points is called as point of contraflexures. Point of contraflexure. So first we will write definition, then I will explain what is meant by point of contraflexure. So please write down the point in a beam, the point in a beam, the point in a beam where bending moment goes from where bending moment where bending moment goes from, where bending moment goes from hogging to sagging, hogging to sagging, hogging to sagging, hogging to sagging, or vice versa, or vice versa, or vice versa. Bending moment, bending moment, bending moment becomes zero, becomes zero, becomes zero, bending moment becomes zero, that point, zero, that point, bending moment becomes zero, that point is called as, is called as, is called as, is called as point of contraflexure, point of contraflexure. Okay, your writing is over. So I will explain this point of contraflexure. Okay, you observe here, this is the overhanging beam, and on that beam, one uniformly distributed load is applied. So due to this load, this is shear force diagram and this is bending moment diagram. So you observe here, at this point, bending moment changes sign from negative to positive. That means hogging to sagging. Or you observe here, at this point up to this sagging nature will be there, after that hogging. That means bending moment changes sign from hogging to sagging or sagging to hogging. And at this particular point, the value of bending moment is 0. This point is called as point of contraflexure. Okay. Please remember, because of definitely one MCQ will be asked on this point of contraflexure. So please remember, at point of contraflexure, bending moment value is 0. And at that point, bending moment diagram changes sign from sagging to hogging or hogging to sagging. Okay. So this is called as point of contraflexure. Then next, we will move towards last theoretical point, relation between, please write down next point, relation between intensity of load, a relation between, a relation between, a relation between intensity of load, a relation between intensity of, intensity of load, intensity of load, shear force, shear force, shear force, and bending moment, and bending moment, bending moment, and bending moment. So we have to see here what is the relation between intensity of load, shear force, and bending moment diagrams. Because of up till now we have discussed that much load is given, and due to this shear force will come and this bending moment will come. But now exactly we will see what is the relation between intensity of load, shear force, and bending moment. So first I will draw beam here, one cross section of beam, and then we will discuss. So suppose this is the cross section of beam. Okay. It may be fixed or simply supported, doesn't matter. So we will take this is beam, and on that beam, suppose this is uniformly distributed load is applied here. Okay. So shear force and bending moment calculations are depend on this type of loading. So this support will not matter here, only type of loading matter here. So here uniformly distributed load is applied, and we will cut this beam in small section. We will cut this beam in small section, or this is we will call wedge. Okay. So we will take this is small cross section at a distance x from this support A side. So we will assume this is ABP. Okay, and we have taken one wedge or one small cross section at x distance from this A point. So this is the dx. This is distance is, we will assume as a dx, and here w kilonewton per meter. Now we will only draw this part. Okay, only we will draw this part. So this part will be likewise. Got it? So after that, this part will be likewise, and this distance is dx. Okay, so here one shear force will be there. Suppose we will assume here this is S, and for equilibrium here S plus ds will be there. S plus ds will be there. After that, we will consider here one moment is there, and here one moment is there, and it is called as m plus dm. M plus dm. Okay, m plus dm. Now we will apply equilibrium equation, or we will consider here equilibrium equation. So for equilibrium, already you know that how to equilibrium, which equations we will consider here. Equilibrium equations, apply equilibrium equations. Apply equilibrium equations. There are total 3 equations: summation h which is equal to 0, summation fv which is equal to 0, and summation moment which is equal to 0. So if horizontal forces will be there, then we will consider. Otherwise, we will consider these 2 equations, vertical forces and movement. So here vertical forces and movements are there. So we will consider only these 2 equations. We will ignore this equation because of in this case there is no any horizontal force. So first we will apply equilibrium equation, that is summation fv which is equal to 0. Okay, so this, for this we will consider upward forces positive and downward forces negative as usual, or sign conventions. So this s is going upward. Okay, this s is going upward direction. So yes plus s. After that, this s minus ds is going downward direction. So minus s plus ds, s plus ds. Okay, after that, here on this part uniformly distributed load is applied. You observe here load is there, and the intensity of load is w. So this again going downward. So minus w into distance is dx, which is equal to 0. Okay, now we will multiply by this minus to bracket. So s minus ds minus w into dx, which is equal to 0. This plus and minus s gets cancelled. Now we will shift this ds to right side. Okay, we will shift this ds to right side. So minus w dx, which is equal to ds. So ds divided by dx, which is equal to minus w. Okay, only I have shift this dx to right side. So ds divided by dx, which is equal to minus w. So this is our first answer. Okay, I will explain here how it comes. So our final equation is ds divided by dx, which is equal to minus w. So we will apply second equation, then I will explain this. Okay, so you will understand easily. So second equation for equilibrium, summation movement which is equal to 0, and for this clockwise movement positive, anti-clockwise movement negative. So this m is clockwise. Okay, so plus m, and this m plus dm is anti-clockwise. So minus m plus dm, m plus dm. After that, this we will calculate movement about this point. We will calculate movement about this point. So it again creates anti-clockwise movement to this point. So minus w into, first we will convert dx into, it will act at dx by 2. After that, we have to consider this s plus ds. Okay, we have to consider this s plus ds, and no, this s plus ds is after that, so we will consider only this. So plus s into dx, s into dx, which is equal to 0. So this minus w into dx by 2. So here square term is there, and this is the very negligible value. So we will ignore this value. So for this, we will write as, okay, but already we have written dx. So we will ignore this term because of here square term is there. So we will ignore this. We will ignore. So what is remaining? Plus m minus dm plus s into dx, which is equal to 0. This plus m and minus m gets cancelled. Okay, this plus m and minus m gets cancelled. Now I will shift this dm to right side. So s into dx, which is equal to dm. So s, which is equal to dm divided by dx, and finally dm divided by dx, which is equal to s, which is equal to yes. Now I will explain what it says. So first derivative of first derivative of first derivative of movement, first derivative of movement, you will get you will get you will get the value of shear force. म्हणजे मुवमेंटचा जर डेरिव्हेटिव्ह फाइंड आउट केला तर त्याच्यावरून आपल्याला काय मिळतो? शियर फोर्स मिळतो. सो दिस इज द रिलेशन बिटवीन मुवमेंट अँड शियर फोर्स. यू विल गेट शियर फोर्स. ओके, अँड हियर you observe here ds and dx. So for first derivative of shear force, you will get intensity of load. म्हणजे जर शियर फोर्सचा डेरिव्हेटिव्ह फाइंड आउट केला तर लोड मिळतो, आणि मुवमेंटचा डेरिव्हेटिव्ह फाइंड आउट केला तर शियर फोर्स मिळतो. सो दिस इज द रिलेशन बिटवीन intensity of loading, shear force and movement. So for this I will give one example below. Okay, I will write here in this space. Okay, so for uniformly varying load, suppose this is uniformly varying load and this is xx section. So for uniformly varying load, the bending moment is in terms of x cube. Bending moment is in terms of x cube. So we will calculate here. Otherwise, so moment is k into x cube. So k we will assume as a constant, k into x cube. So we have to take first derivative of this. We have to take first derivative of this. Okay. So this is suppose moment. Okay. Now the derivative of this k into x cube is 3. Yes, काय असतो डेरिव्हेटिव्ह? 3kx square, which is equal to this is shear force. हे मुवमेंटचं इक्वेशन आहे. हे काय झालं तुमचं? शियर फोर्स इक्वेशन. आफ्टर दॅट वी विल टेक फर्स्ट डेरिव्हेटिव्ह. दॅट मीन्स 3 into 2 is 6k into x, which is equal to intensity of loading. इंटेन्सिटी ऑफ लोडिंग. बघा, ज्यावेळी आपण युनिफॉर्मली डिस्ट्रीब्युटेड लोड घेतला होता त्यावेळी त्याचा लोड असा इन टर्म्स ऑफ के इंटू एक्स होता, कारण इथे काय होतं तुमचं ट्रायंग्युलर पोर्शन, and area of this triangular portion 1/2 into base into height. So area in terms of x. After that shear force in terms of x square, and bending moment of this particular is x cube. So that means the first derivative of movement you will get shear force, and first derivative of shear force you will get intensity of loading. So this is the relation between intensity of loading, shear force and bending moment. Okay, please write down fast. This is the important point. Then we will take one example. Suppose one beam is given and on that inclined load is applied. Then how to solve this inclined load equation? So today we will conclude this unit number 5. Okay, please write down fast. Let me know after your writing is over. So we will take last example. If your writing is over, shall I take example? Yes, those students are attending online. Please give me reply.
Yes, ma'am.
Okay. So we will solve this one example. If inclined loads are given, then how to solve this example? Suppose here huge support is provided and here a roller support is provided. So this is a point. This is a point. At B, one inclined load is applied and intensity is 20 under root 3. 20 under root 3 and inclination angle is 60 degree. This is suppose B point. After that at C point, one inclined load is applied. Here angle is 30 degree. Angle is 30 degree and intensity is here 60 kilonewton. Here intensity is 60 kilonewton. This is C point. After that at D point again inclined load is applied and this is angle is 45 degree and intensity is 40 under root 2. 40 under root 2. And this is D point and last one this is E point. So distance between A to B is 2 meter, distance between B to C is again 2 meter, distance between C to D is 2 meter and D to E is 2 meter. So this type of questions will be asked at that time. First you have to resolve these three forces. Okay, already you have resolved forces in engineering mechanics. Okay, so here we will consider the load at B point. So at this here inclined load is applied and this is horizontal. Okay, this is horizontal, this is inclined and this intensity of incline is 20 under root 3. Suppose we will consider this vertical and this inclination is 60 degree. Okay, inclination is 60 degree. So we have to find out this vertical and horizontal forces. So we have to resolve this. So vertical, that means we will apply here sine 60. So sine 60, which is equal to, sine 60 means this, ज्या 60 च्या समोरची साइड, vertical divided by, this is hypotenuse, that is 20 under root 3. So V, which is equal to 20 under root 3 into sine 60. Okay, now we will talk about this H. Okay, so H means cos 60. Okay, cos 60, which is equal to H divided by 20 under root 3. So H, which is equal to 20 under root 3 into cos 60. So accordingly you calculate and tell me V, which is equal to, and H, which is equal to how much. V, okay, V 30 kilonewton, and H, which is equal to, okay, H, which is equal to 17.32 kilonewton. So this is the resolution of this inclined force. Now we will resolve this second force. Okay, we will resolve this second force. So second force is likewise here vertical and here horizontal. That means this horizontal is going in this direction and vertical is downward direction. So this hypotenuse is 60. This is horizontal and this is vertical, and angle is 30 degree. Okay, so I will write here sine 30, which is equal to V divided by 60. Okay, V divided by 60. That means V, which is equal to 60 into sine 30. Okay, and after that cos 30, which is equal to H divided by 60. That means H, which is equal to 60 cos 30. So you calculate V and H and tell me how much. V, okay, V 30 and H, which is equal to, okay, 51.96. We will round figure this 52. Okay, we will round figure this 52 kilonewton. So these are the vertical and horizontal forces at C point. Now we will resolve this third inclined load. So I will draw figure first here for this. So this is again likewise inclined, this is vertical and this is horizontal. So horizontal is this is and vertical. So here angle is 45, angle is 45 and this inclined is 40 under root 2. I think sine 45 and cos 45 have same value. Okay, so according to this we will write, suppose this is V, this is H. So V, which is equal to 40 under root 2 sine 45, sine 45. So V, which is equal to how much? And H, which is equal to 40 under root 2 cos 45. So I think 40 value is there, right? Yes, 40 kilonewton and H also 40 kilonewton. So likewise, first you have to resolve these inclined forces and after that you have to draw final diagram. Okay, now we will draw final diagram of our beam. Final diagram. So this is AE beam. Okay, this is AE beam. Here one vertical and one horizontal force will be there. B point, C point, and this is D point. Okay, now we will write here. So suppose this is our A point. You observe here hinge support. For hinge, one vertical and one horizontal force will be there. So this is vertical and this is horizontal. So this is called as HA and this is called as RA. Okay. So now At B point, vertical force, intensity of vertical force is 30 kilonewton. So we will write here 30. And at same point, horizontal force is 17.32. But the direction is left to right. So here force is applied 17.32. So these are the forces acting at B point. Now we will draw for C point. Okay, suppose this is C. So at C, vertical force is 30 and downward. So this is 30 and downward. Now you observe here, at this point, horizontal force is right to left and intensity is 52. So we will draw likewise. This is 52. And at D point, again here, downward vertical force and intensity is 40. And here again, horizontal is right to left. So here, right to left, this is 40. And at E point, only one vertical force is there because of roller support, and for roller support only vertical reaction is there. So this is called as RE. Now this is our beam. Likewise, previous example. And now we will apply our regular step. So before that, only one step you have to add here, resolution of these inclined forces. So you have to first resolve these inclined forces, and after that you have to draw figure in proper format, and after that we will apply our first step, reaction calculation. Reaction calculations. Reaction calculations. So in that again A and B part, summation FV. Now here three types of forces are there: horizontal force, vertical force, and due to this movement will be there. So we have to apply three equations of equilibrium: summation horizontal forces, which is equal to 0. So in this we will consider only horizontal forces. Okay, so horizontal force likewise we will consider positive, and horizontal force likewise we will consider negative. So according to this, HA positive, so plus HA. After that, this 17.32 again positive, so plus 17.32. After that, this 52 minus, and after that this 40 minus 40, which is equal to 0. Now we will shift this all to right side. You calculate and tell me HA, which is equal to how much? Yes, 74.68. Wait, I will start camera. So HA, which is equal to 74.68 kilonewton. So this is the first equation of equilibrium. After that, we will apply B part, and B part is related to vertical forces. Okay, B part is related to vertical forces. So we will write summation FV, which is equal to 0. Second, B is summation FV, which is equal to 0. So here RA and RE. Upward forces we will consider positive, downward forces we will consider negative. So RA and RE going upward. So RA plus RE. RA plus RE. Then this 30 going downward. So minus 30, again 30 going downward, again 40 going downward, which is equal to 0. So RA plus RE, which is equal to how much? 30, 30, 60, 100 kilonewton. This is equation 1. After that, C part, summation moment, which is equal to 0. We will take moment at A point. So minus RE. Okay, clockwise movement positive, anti-clockwise movement negative. So RE creates anti-clockwise into perpendicular distance is 8 meter. After that, this 40 creates clockwise movement. So 40 into 6 meter plus 30 into 4 meter plus, because of this 34, and again this 30 into 2, which is equal to 0. We will shift RE into 8 to right side. So 40 into 6 plus 30 into 4 plus 30 into 2. How much? How much? 420 only. 12 180. किती 420. So 420 which is equal to 8 RE. So RE which is equal to 420 divided by 8. Now you tell me RE which is equal to how much? Yes, 52.5 kilonewton. 52.5 kilonewton. Now we will put this value of RE in equation 1. So put RE in equation 1. So our equation 1 is RA plus RE which is equal to 100. So RA which is equal to 100 minus 52.5. You calculate and tell me the value of RA which is equal to, yes, 47.5 kilonewton. 47.5 kilonewton. So these are the reactions calculations. After that we will calculate shear force and bending moment. Okay. Now I will take new slide. First I will draw figure and then we will calculate shear force and bending moment. Suppose this is AE beam. This is AE beam, here A point, here E point. A reaction at A, RA which is equal to 47.5 and RE which is equal to 52.5. 52.5. After that here 30 kilonewton, here again 30 and here 40 kilonewton. Here one horizontal force 17.37. Here likewise horizontal force 52 and here 40 and here HA force is there. Please mark here HA. I will mark by different color so you will get. Here HA force is there and HA which is equal to, already we have calculated, HA is 74.68. 74.68. This distance is 2 meter, 2 meter, 2 meter and 2 meter. Now we will calculate shear force. So we will start from this A point. Shear force at A which is equal to, upward forces we will consider positive. So here plus 47.5 kilonewton. Plus 47.5 kilonewton. After that, in between A to B, there is no any force. Okay, there is no any force. So we will calculate at B. So shear force at B, which is equal to, up to B point, shear force is 47.5. But at B point, downward 30. So minus 30, which is equal to. So you calculate and tell me how much? Plus 17.5 kilonewton. After that, you observe here in between B to C, there is no shear force. So we will calculate at C. So shear force at C which is equal to, up to C point force is 17.5 and at C point downward 30 force is there. So minus 30 which is equal to minus 12.5 kilonewton. Now you observe here at this point shear force changes sign, plus to minus. That means we have to find out zero shear force location for this. Okay. After that we will calculate shear force at D. Shear force at D. Shear force at D which is equal to, up to D point force is minus 12.5 and at D point downward 40. So minus 40 which is equal to minus 52.5 and last shear force at E which is equal to minus 52.5 up to E point and at E point upward force, so plus 52.5, which is equal to 0 kilonewton. Okay, so these are the shear force calculations. Now we will calculate bending moment. So next step number 3, bending moment calculations. Bending moment calculations. We'll start from this E point. Okay. So you tell me bending moment at E, which is equal to how much? 0. Because of force is there, but perpendicular distance is 0. So bending moment at E, which is equal to 0 kilonewton meter. After that, we will calculate at D. Bending moment at D, which is equal to, so for this span is likewise, this is 52.5, this is E point, and this distance is 2 meter. I have not considered this 40 kilonewton force downward because of perpendicular distance is 0. So this 52 pushes upward, so plus 52.5 into 2, which is equal to 105 kilonewton meter. After that, we will calculate bending moment at C. Bending moment at C, which is equal to, for this span is likewise here 52.5, here 40, this distance is 2 and this distance is 2. This is our F point, this is D and this is C. So this 52 pushes upward. So plus 52.5 into 2. No, 2 or 4. Yes, 4, because of we are calculating moment at C point. So 52.5 into 4. After that, this 40 pushes downward. So minus 40 into 2. So you calculate and tell me bending moment at C, which is equal to how much? 130. Okay, 130 kilonewton meter. 130 kilonewton meter. After that, we will calculate bending moment at B. Bending moment at B. We will calculate from this left side because of less number of calculations will be there. So at B, this is suppose our A point, and this distance is 2 meter, and here 47.5, and this is our B point. So you calculate this pushes upward, so plus 47.5 into 2, which is equal to, yes, 95 kilonewton meter. 95 kilonewton meter. And last point is remaining bending moment at A. Bending moment at A, which is equal to 0 because of force is there, but perpendicular distance is 0. These are the bending moment calculations. Now, one additional step will be there, thrust calculation. So these horizontal forces are there. That's why we have to do next step, that is thrust calculations. Thrust forces. For thrust forces. Thrust forces. So for this, we will consider this type of force positive and this type of force negative. Okay. So thrust at A. Thrust at A, which is equal to at A right side. So plus 74.68 kilonewton. After that, thrust at B, which is equal to same shear force calculations likewise. Okay. Up in between A to B, there is no horizontal force. At B, only one horizontal force. So plus 74.68 plus 17.32. So which is equal to plus 92 kilonewton. After that, we will calculate at C. So thrust at C, which is equal to up to C point plus 92. So plus 92 minus, because of this going this direction, so minus 52, which is equal to plus 40 kilonewton. After that, we will calculate thrust at D, which is equal to, so up to D point plus 40, and at D point force is going right to left, so minus 40, which is equal to 0 kilonewton. And at E thrust is 0 already because of there is no force. So these are the thrust calculation. Now our last step is shear force and bending moment diagram. I will repeat this like plus 74.68 plus 17.32. Now we will draw shear force, bending moment and thrust diagram. Yes, maximum bending moment काढण्यासाठी ना. Okay. We will calculate in previous slide na. No, shear force calculations are there. Okay, so we will calculate here below. So shear force changes sign from at this point. Okay, at 12.5. So in between C to D, in between B to C, in between B to C, that means shear force location, shear force, zero shear force location. Okay, from B. So 17.5 minus 30 into x, which is equal to 0. So 17.5 divided by 30, which is equal to x. So x, which is equal to how much? Zero 0.58 meter from B. So from this B, suppose here shear force is 0. Now you have to calculate maximum bending moment. Okay, maximum bending moment I will write here. So maximum bending moment, which is equal to, so span for this is 52.5. Here 40 kilonewton is applied. This is 2 meter. Here 30 kilonewton is applied. Span is 2 meter, and in between B to C na. So total is 2. So 2 minus 0.58 is, I think, 1.41. 1.41. This is suppose our small a point. This is C and this is D. So this 52.5 pushes upward. So plus 52.5 into perpendicular distance is 1.41 plus 2 plus 2. 4, 5, 5.41. 5.41. After that 40 pushes downward, so minus 40 into 3.41. After that this 30 pushes downward, so minus 30 into 1.41. So you calculate and tell me maximum bending moment, which is equal to how much? 105. Something went wrong. Because of already movement is here 130. Please calculate once again. Okay, so please in this particular type of problem, here horizontal forces also acting. That's why we are unable to calculate exact maximum value. So only we will calculate location of zero shear force, but maximum value we will not get particular value because of horizontal forces also there. So only we will calculate shear force location, and after that we will draw shear force and bending moment diagram. So because of this RA and RE, after doing all calculations we will get. That's why only we will calculate here zero shear force location, or this is also not necessary for this inclined type of problem. So we will draw bending moment and shear force diagram. Last step, shear force diagram and bending moment diagram. So first I will draw figure. So here, suppose this is A point, this is E point. On that, this is 2, this is, and this is. After that, we have to extend these all lines. Here we have to draw total 3 figures: shear force, bending moment, and thrust diagram. First, I will close this figure. So this is A, B, C, and D. Here 30, here again 30, and here 40. Here 40. This is E point. Here 40 horizontal. Here 30 horizontal. No, 30 not. 52, no. Here 52. And here 17.32. And here HA is applied 74.68. Okay. So at A point, shear force value is, you see here, 47.5. So this will above baseline. So 47.5. After that, shear force at B. So up to B point value is same because of there is no force. At B plus 17.5, but it goes downward. So up to this, suppose 17.5. After that, shear force at C minus 12.5. So it will be go below baseline. So minus 12.5. After that, shear force at D. So C to D is constant, and at D point shear force value is minus 52.5. So it will be go below base, sorry, again below. Then in between D2 E no force, so diagram is constant, and at E point shear force is 0. So this is the shear force diagram. So above baseline diagram is positive and below baseline diagram is negative. So this is A, B, C, D, and E. Here value is 47.5. Here also 47.5. Here 17.5. 17.5. Here 12.5. Here also 12.5, and after that here 52.5. Here also 52.5, and here 0. So this is the shear force diagram. After that we will draw bending moment diagram. So the value of bending moment, all values are plus or minus. I think all values are plus. So we will draw. So this is the baseline. Bending moment at E. We will first mark points. Bending moment at E is 0. Okay. After that, bending moment at D is 105. Bending moment at D is, suppose here, 105. After that, bending moment at C, 130. Bending moment at C is 130. After that, bending moment at B, 95. So below 100. This is 95, and bending moment at A is 0. So here only point loads are applied. That means connection is linear. So this is the bending moment diagram. Whole diagram is in positive. This is we will call bending moment diagram. I think thrust values are also positive or negative. I think one value is no, not all values are positive. Huh? Yes. So last diagram we will draw thrust diagram. Okay. So thrust at A 74.68. So we will draw up to this. After that, thrust at B. So in between A to B, not force is there. So A to B is constant. After that, thrust at B is 92. We have to, we will draw here 74.68 up to this point only. After that, up to this constant. Because of there is no any force in between A to B. After that, thrust at B is 92. So that means it will go again upward. Okay. So after that, in between B to C, there is no force. So it will be constant. After that, at C point, how much thrust? Plus 40. So I think below this. Okay. After that, from this C to D, 4 diagram is constant. And at D, thrust is 0. Because of at E, there is no horizontal force. So diagram is likewise. Okay, here continuation. Huh? Because of this, you are unable to see. And this is thrust diagram. Thrust diagram. This is 74.68. Here also 74.68. Here 92. Here again 92. Here plus 40. Here plus 40 is there. And here value is 0. Please mark here 0. And here also 0. This is the thrust diagram. So if inclined load is applied, at that time you have to solve this. You have to apply these steps. So please write down. Okay, now our unit number 5 is over. In next lecture, we will start unit number 6. Okay, I will suggest you take screenshots. We will solve some MCQ on this SFD and BMD. So you will get idea how or which type of MCQ will be asked on this topic. So please take screenshot first. Then we will discuss some MCQs on this unit. Okay, if you had taken screenshot, shall I close this? Now I will share this data. Okay, my screen is visible to you or not?
Not ma'am.
Wait. I will share. Now visible?
Yes, ma'am.
Okay. So please see here. MCQs on shear force and bending moment diagram. So first, the bending moment at the fixed end of a cantilever beam is. Okay, so likewise MCQ will be asked here. So you have to remember, this is our cantilever beam. Suppose this is our cantilever beam and this is free end. Okay, so question is the bending moment at the fixed end of cantilever beam. So maximum, minimum, WL by 2 WL. So bending moment at fixed end is maximum. So you have to remember this is. So anyone please at least try to draw here bending moment diagram shape. Anyone? How bending moment will come here? Shape of bending moment diagram is likewise. Okay, so here minus WL is there. Okay, here WL is given, but plus WL is given, and our answer is minus WL. So you prefer this maximum. After that, second, the bending moment diagram for a cantilever with point load. Okay, so this is the cantilever with point load at the free end. So here suppose point load is applied at the free end will be. This is cantilever beam and point load is applied at free end. So at that time, a triangle with maximum height under fixed end. म्हणजे इथे किती असणार आहे हाईट तुमची फिक्स्ड एंडला मॅक्सिमम असणार आहे आणि फ्री एंडला किती असणार आहे 0. सो अवर आन्सर इज लाईकवाईज. First option is a triangle with maximum height under free end. At free end, bending moment is 0 and at fixed end, bending moment is maximum. So shape is triangle with maximum height at under fixed end. Okay, after that, we will move towards third question. So third question, for a simply supported beam loaded with point load, the bending moment will be. The bending moment will be. So triangle, parabolic curve, cubic curve, or none of these. Simply supported beam is given. So simply supported beam is likewise. Loaded with point load. That means here point load is suppose applied. The bending moment diagram will be likewise. So here for point load diagram is linear. Okay. For UDL diagram is parabolic, and for UVL or if x raised to power is 3, then cubic polynomial. Please remember. So simply supported beam and point load at that time diagram is triangle. After that, next question. For a simply supported beam of span L. Okay, so suppose this is simply supported beam and here span L with point load W at center. So here center point load is applied. The maximum bending moment will be. So reaction is WL by 2 and here WL by 2. And the bending moment is WL by 2 into 1 by 2, that is WL by 4. So bending moment is WL by 4. Okay, so option C is correct. Here WL is given, WL by 2, WL by 2 the reaction, and WL by 4 is correct answer. After that, we will move towards next question. So for a simply supported beam of span L, so we will draw here simply supported beam span L with UDL W kilonewton per meter over the whole span. That means over the whole span, W kilonewton per meter load is applied. The maximum bending will be. So here shear force or sorry reaction is WL by 2 and here WL by 2 and bending moment is maximum or diagram is likewise and bending moment is WL square by 8. So WL by 4 is wrong. WL square by 4 is again wrong. W into WL square divided by 2 is again wrong. Correct answer is WL square by 8. So question will be asked likewise. After that, next question. At the point of contraflexure, please read carefully. Yeah? At the point of contraflexure, bending moment is minimum, bending moment is maximum, bending moment is either 0 or changes sign, and none of these. So bending moment is 0, or it changes sagging to hogging or hogging to sagging. That means it changes sign. So MCQ likewise will be asked on your in the examination. Okay. We will solve again next MCQ. Okay. So first I will clear all drawings. Next, the point of contraflecture occurs in case of cantilever beam, simply supported beam, overhanging beam, all types of beam. Please remember, point of contraflecture occurs only in overhanging beam. In overhanging beam. After that, here one question is given. A cantilever beam of length is 2 meter. Uniformly distributed load is applied 150 kilonewton, no, Newton per meter. 150 Newton per meter over its whole span. The maximum shear force in the beam will be. Anyone please tell me how to calculate shear force? Yes, 150 into 2, because of we have to convert this UDL to point load. So 150 into 2, shear force is 300. So likewise questions will be there. So small calculations will be asked in examination. Difficult calculation does not ask because of only 1 hour time limit is there. Okay. So questions will be likewise. I will share this MCQ booklet in teaching diary, or already I have posted in unit number 3. From that you also study MCQs. Okay. So today we will stop here. In next lecture, we will start unit number 6. Okay. Thank you for attending lecture. Thank you.